Students, in this video we are going to see about cache optimization. In program power optimization, there is another one technique called cache optimization. A loop nest is set of loops, one inside the another. Loop nests occur when we process arrays. A large body of techniques has been developed for optimizing loop nests. The rewriting a loop nest changes in order to which array elements are accessed. This can expose new parallelism opportunities that can be exploited by larger stages of the compiler, and it can also improve the cache performance. Program level energy and power analysis and optimization. The power consumption is the most important design metric for battery powered systems because most of the embedded products are battery powered. It is increasingly important in systems that runs off the power grid. The fast chips run hot, and controlling power consumption is an important element for increasing reliability and reducing system cost. Power consumption reduction techniques are follows: to replace the algorithms with other consuming less power, by optimizing memory access able to significantly reduce the power, to turn off the subsystems of CPU chips in a system in order to save power. So measuring energy consumption for piece of code, we can use this technique. Program energy consumption, how much energy of the program consumes. To measure power consumption of an instruction or small code of fragment, it is used to execute the code under test over in loop. By measuring the current flowing into the CPU, we are measuring the power consumption of the completed loop, including both the body and the other code. By separately measuring the power consumption of a loop with no body, we can calculate the power consumption of the loop body code as difference between the full loop and the bare loop energy cost of an instruction. So by using this technique, you can measure the energy consumption of the piece of the code. By using this piece of the code, we can calculate the overall program power consumption. So list of factors contribution for energy consumption of the program. Energy consumption varies somewhat from instruction to instruction. The sequence of instructions has some influences. The opcode and the locations of the operand also matters. So how we can improve the energy consumption? There are steps to improve energy consumption. Try to use registers efficiently. Analyze cache behavior to find the major cache conflicts. Make use of page mode access in the memory with system whenever possible. Then moderate loop unrolling eliminates some loop control overhead. When the loop is unrolled too much, power increases also. Software pipeline reduces the average energy per instruction. Then eliminating recursive procedure calls wherever possible saves power, getting rid of the function call overhead. Then tail recursion can often be eliminated. Some compilers do this automatically. Analysis and optimization of program size. Memory size of a program is determined by the size of its data and instructions. Both must be considered to minimize the program size. Data provide an opportunity to minimize the size of program. Data buffers can be reused at several different points in a program, which reduces the program size. Sometimes inefficient program keeps several copies of data. Identifying and eliminating duplication can lead to significant memory savings. So by minimizing the size of the instruction text and reducing the number of instructions in a program, then reduce the program size. Proper instruction selection may reduce the code size also. The special compilation modes produce the program themselves of dense instruction set. Program size of course varies with the type of program, but programs using the dense instruction set are often 70 to 80% of the size of the standard instruction set equivalents. So now we are going to see about the program validation and testing. In complex system needs testing to ensure the working behavior of the systems. Coming to software testing, used to generate a comprehensive set of tests to ensure that the system works properly. The testing problem is divided into sub-problems and analyze both each sub-problems. So types of testing strategies: white or clear box testing and black box testing. In white or clear box testing, generate tests based on the program structure. In case of black box testing, test without looking the internal structure of the program is known as a black box testing. So coming to clear box testing, testing recursive control or data flow graph of program source code. To test the program, exercise both its control and data operations. To execute and evaluate the test, control the variables in the program and observe the results. The following three things to be followed during a test. That means provide program with the inputs for the best test, then execute the program to perform the test, then examine the outputs to determine whether the test was successful or not. So coming to types of clear box testing strategy. One is branch testing, another one is domain testing, another one is data flow testing. So coming to branch testing, this strategy requires true and false branches of a conditional. Every simple condition in conditional expression to be tested at least once. So here we can see if x equal to good pointer and x less than field 1 is equal to 3, printf got the value. The bad code we actually wrote, the x equal to good pointer and x field 1 less than 1, printf got the value. You can see the the difference between these two if-else conditions. In previous condition, we can assign the value good pointer is equal to x, but here we are not assigning the proper value to the x, so we are using simple one equal symbol. So coming to data flow testing, if you use use analysis, that means definition use analysis, then it selects path that have some relations of the program functions. The compiler use the definition uses analysis of optimization. A variable value is defined when an assignment is made to the variable. It is used when it appears at the right side of the assignment. So next we are going to see about the block path testing. Block path test generated without knowledge of code being tested. It have a low probability of finding all bugs in the program. We can test every possible input combination, but some rules help us a reasonable set of inputs. So in this under the block path testing, there is random test. Random values are generated with the given inputs. The expected values are computed first, and then the test inputs are applied. Then recursion test. When tests are created during earlier or previous versions of the system, those tests will be saved, applied to the later versions of the system. It simply accesses current version of the code and possibly accesses different bugs. In digital signal processing systems, signal processing algorithms are implemented to save the hardware costs. Data sets can be generated for the numerical accuracy of the system. These tests can be often be generated from the original formulas without reference to the source code. Thank you.